Hi, I'm Kent. Let's make a new slip casting mold for a bowl. In this video, I want to go from idea through 3D printing to pouring plaster to creating a slip cast bowl. This was the concept that I had. I basically started as a sketch, and then I used Shapecast to create this design proof, and then it went ahead and created all the pieces we needed to 3D print to make a mold. We assembled those and created this plaster mold here. And we slip cast this spot here, which is bone dry. And I'll fire it in my next kiln firing. Let's do the same thing, only for a bowl. So I've been sketching out a few different bowl designs, and while I have some more interesting ideas, I think for this one I'm just going to go with a very simple bowl. So I took a couple of these and then drew them a little bit bigger. And then I went into my cabinet and started measuring some existing bowls that I liked, and I got some critical dimensions here that I want. So I want something that's about 65 millimeters tall. I want the foot to be about 30 millimeters in radius, the top to be about 80 millimeters, and I want a very shallow foot like my pot that I just showed you, about 2 millimeters, and a spot for the glaze to break. So let's go ahead and draw this up in Inkscape. All right, here is Inkscape. This is an SVG editing program that we're going to use to draw our pot, and we'll use this to upload to Shapecast. One of the first things you want to do is make sure in document properties, it doesn't matter what the page size is, but we want the page size to be in millimeters so that Shapecast can process it properly. All right, so I want to go ahead and basically block out the bowl here. And I like using a rectangle, so I'll start up here at the top and go down. And I want the diameter to be 80, or basically drawing the profile of the pot just from the side. I want the height to be 65. So that's good. We can go ahead and put this at the origin. So at 0, 0. Zoom in a bit since we have the space. And then I want the foot down here, 30, and the height to be 2. I'll go up here and turn snapping on. Zoom in a little bit. I'll drag that down to the corner. And then I want a small break here at the bottom for the glaze to stop. All right, so I want a line. So click, drag out. If I hold Control, it'll constrain it. So if you look at the very bottom, you can see it's 30 degrees, 45 degrees, and I want that distance to go to 5 millimeters. 499, that's good. So I click, push Enter, now I have a line. I want to go ahead and drag this down here. So I want the bottom to be aligned. Yep, so that bottom here is on the foot of the pot, and I want this right side to be the outside edge of my foot. Let's go ahead and draw a line here. So we're going to go from this corner here down to the bottom to the edge of that line there that we just drew, and this is snapping for us, so it's just doing all that automatically. And up to the top right, push Enter, go ahead and make that black, make it a little bit thicker so we can see it a little bit better. Now I don't want this very angular, so we can go ahead and adjust this a little bit. So I'm going to take the bottom here, first I'm going to turn off snapping. So now I'm going to take the bottom here and swoop it up a little bit. If you click here on this node, you can see that. I actually want that horizontal. That's good. I want this little segment here to be swooped in just a tad. And finally, going back to my picture, I want my bowl to kind of come down like this. So you can move it around this way, or again, you can grab onto the handles here and adjust it. You just want to be careful that you don't have any undercuts. So pull that down. Make it swoop down a little bit more. There we go, there's the bowl. So we can save this, although we can't upload it because there's more than one curve in here and Shapecast will get confused. It only needs the profile for the pot. So let's save this. Let's call this bowl. And I'm actually going to save a copy as well. And call it bowl clean. All right, so here's bowl clean. So now we can take everything. So select everything except for the pot. Delete it, and so this here should be the profile of our bowl. think I like that. So now we can go over to Shapecast. So we'll go ahead and click on Choose SVG, select the clean file, and it'll render a preview. So now we can look at this. There's a little bit of banding here, that's just the preview rendering it. And it doesn't have any thickness at all, so this is really just the outside profile of the pot. It's to give you an idea of what it's going to look like. So do I like that? I can zoom in here a little bit. I think so. So let's go ahead and try that out. My clay shrinkage factor is 13. You can change that, and here's instructions. I'm going to make a 2-part mold. I think this will fit on my printer. I don't need 4 parts, and I want to use the outer mold to contain the plaster. So submit it for processing. Let me go over to designs, and it's processing the proof right now. So the design proof is basically the first step where it will create an STL file that we can print out and actually hold on to. I found that printing them out really makes a big difference. I've tried a few different designs where on the computer they looked okay, but it wasn't until I printed them out that I had a better sense of if I liked it or not. So this is still processing, click on designs. All right, so here we go. Now we get a zip file. Download that. And when you're ready, you can either proceed or cancel. All right, so here are the files it produced. So at first it creates a README, which right now just has 1 line in it. So it says this is about 735 millimeters or 24 ounces, 3 cups. And then here is the design proof. So let's go ahead and open this up and print it. So I have a Bamboo P1P, so this is the software for that. You can open it up, you can see it. So let's go ahead and print this out. So I want it on the draft settings so it can go as fast. So we can go ahead and enable supports, and I like the tree supports. So let's go ahead and slice that. Let's see what it does. All right, so it wants to support the bottom here, which kind of makes sense, and then it should be able to be okay. Just kind of scrub up and down. The way Shapecast works is it basically is making this line very thin, so it's only a couple of perimeters wide. This isn't as thick as the pot, but it's so that it can print out really fast. And in particular, it says this will print in basically 2 hours, 2 and change. So I think I like this. Let's go ahead and send it to the printer and see what we get. I'll be back when I can hold it in my hands. And here it is, off the printer. Went ahead and pulled off the supports. The bottom is a little bit rough because of the supports, but overall we can get a good sense of how this feels. I like the outside curve. I think that's what I'm going for. The foot I'm not exactly sold on. I played around with a few other things on the computer and tried out some different ideas, but none of them seemed any better. So I think I'm going to go ahead and go with this and see how I like it. I'm definitely a firm believer in trying many things and iterating, and we can go ahead and revisit it in the future if we really don't like it. But I think for now it's good enough. So next up, we need to go ahead and tell Shapecast that we're happy with it so we can generate the STLs, and then we can print those out for all the different mold pieces. All right, so Shapecast is right where we left off, so we want to go ahead and click Proceed. So we approved the design proof, and now it's going to go and process it. So it's processing it for the final. Depending on how busy the server is and how complex the design is, this usually takes a few minutes. All right, and there we go. We can go ahead and download this zip file. And you'll notice a few other things. So the README has been updated. So it's given us an estimate for the amount of plaster we're going to need. We have the inner mold. This is what's actually going to form the pot. We have the bottom of the mold. And we have the outer mold. This will contain the plaster. Let's go ahead and print these out. All right, there we go, all sliced. Looks like it's going to take about 10 hours. So that means I'll be able to print it this morning, and tonight I can start the next print. So I have this on an extra fine setting, so it's a relatively small layer height. And then again, the tree supports. And we can go ahead and slice down through. So this looks good. Go ahead and send it. All right, these will take a little while to print, so let's come back when I have them all off the printer. And here are all the pieces off the printer. This one barely fit in one piece, but it did fit. So the inner mold, this is the one that will actually form the surface of the pot. It came out pretty well. So this here is the slip well. I have a few artifacts from printing, but not too bad. So there's a bit of a seam line here, and then we have a few kind of steps here. These should sand out. I think I'll go ahead and prime this and sand it as well so we can get it nice and smooth. You can use it as is and just clean it up in clay form if you want. This is the bottom ring. It's in two pieces. We will CA glue this together. This will form the bottom of the mold. This one did barely fit. And then likewise, this is the outer mold that contains the plaster. So this will be the bottom, the inner mold, and the outer mold. And so we'll go ahead and pour plaster into here after we've assembled everything. This one had a few hanging strands of filament, so it was on the edge of needing supports, but I just cleaned those up. So we'll have a little bit of a rough spot in the plaster, but it should be just fine as is. I'll go ahead and add this form onto the gallery and shape cast, and I'll go ahead and split it into 4 parts for you. So that way, if you have a smaller printer, you won't have any problems. That just means you have 4 parts to deal with instead of 2. All right, so for assembling the mold, we need to do a few things. We need to add threaded inserts to all of these larger holes here. These here are for bolts. And we'll do that for all of the pieces, and then we wanted to go ahead and do the surface prep for the inner mold so it's nice and smooth. So for the ring, I just use some CA glue. This doesn't need to come back apart. And some paper here on my bench so I don't glue it down to my bench. Try to get it aligned. And some activator. And I usually put a little bit extra just to make sure it doesn't come apart. We don't want plaster leaking. And then flip it over and get the back side. And get it just so it's nice and strong. All right, done with the CA glue. All right, next up are the threaded inserts. These here we'll go ahead and heat set into the PLA. I'm going to start with the inner mold. So we need inserts all around here so we can secure it down to the bottom. I went ahead and removed some of the supports here. These I'm going to use as a handle so I can go ahead and prime this. So I've got my soldering iron here set for about 225C. I've got an old soldering tip on here. It's all beat up. And you can just use a cheap soldering iron if you want. The threaded inserts have a fat end and a narrow end. The narrow end goes down into the hole. Just a little bit of gentle pressure while it heats up. Just like that, and we'll go all the way around. It should only take a few minutes. Nice thing about these threaded inserts is it allows us to attach and reattach things. So if we want to make multiple copies of the plaster, we can do that. And it gets rid of things like tape or silicone or stuff like that, which I found just messy. Now for the outer mold, you need to go around one side and across the bottom, same thing. All right, there we go. There's all the threaded inserts for the outer molds. So across the bottom, up the side, and the same here. So we're all done with the inserts, so let's do a little bit of sanding to clean up these molds. Normally the outer molds I use straight off the printer, but since we had a few overhang issues here, I'm just going to go ahead and sand it real quick. This won't impact the functionality of the mold at all, since this is the outside, but I don't want the filament getting stuck. And this is just some 120. All right, those should be better. I need to dust those off before we use them. And then for the outer mold, I want to deal with the seam line here and the foot where we have these artifacts from it finishing off the print. That I want to be less aggressive. So here I have some 220 and I just want to smooth this out a little bit. And this is the reason we print this in this orientation. So any of the supports are on the inside. They basically don't impact the surface at all. These are just the few things that are left from the FDM printer. You could also use a resin printer. I don't have one. I think they're pretty messy. I'd rather do this little bit of work right now. Who knows, maybe in the future I'll change my mind. All right, that's much better. So that is the surface of the pot. I don't bother with the slip well at all. It's just fine. So I'll go ahead and dust this off really well, and then I'll put on a couple of coats of this filler primer. This basically builds up all of the little recesses, and then you sand off the top and get a nice smooth surface. I'll go ahead and do that off camera, and we'll come back once I have it all primed. The foot here is now nice and smooth, and those seam lines have disappeared. It's not perfectly smooth, however, by the time this transfers into the plaster and then into the pot, I think it is very much good enough. The last step we need to do with our mold prep is to go ahead and attach this neoprene gasket. This is what will prevent plaster from leaking. So the threaded inserts in the bolts are the mechanical connection, and this is the watertight connection. So these grooves here in the ring, as well as the groove here in the outer mold, are for that gasket. They're sized specifically for this gasket. This has an adhesive backing on it. Basically just stick it down, and you want to hold it back so it's not up against the ridge. That way it doesn't get stuck between two plastic pieces. And it's pretty easy to bend around the corners. It buckles up a little bit, but I have not found that to be an issue. And then overlap it by just a bit and snip it off. So this is the part for the inner mold. We need to do the outer mold. There's no recess here in the bottom. Just hold it over the threaded inserts. I got lucky, I had just enough. Push that down nice and tight. Make sure it's adhered. And last but not least, do the same thing for the inner mold. And this we want to hold towards the inside, since the outside is where the plaster is. All right, that should be all the gaskets. And to double check, we can do a rough assembly. So we want gasket on gasket for all the connections. So this one here mates with the inner side. These two here will push together. And on the bottom, we have a gasket all the way around that pushes on the outer gasket. So we got them all. Next, we'll go ahead and use a bunch of bolts to go ahead and put this together. All right, flip this upside down, and since this is the surface we need to keep clean, I'll put it on a piece of paper. And I like to mark a couple of spots where the inserts are, since they're all hidden. I forgot to do that ahead of time, so here's one. Should be one on the other side, right around here. All right, take the ring. One of my marks is right here, and the one's right here, so that looks pretty aligned. Careful not to oversnug it, you don't want to crack the PLA. Now the rest of these holes should already be aligned. And there's the inner mold attached, just like that. I'll make sure the seam here is nice and tight. Looks good. Now I like to assemble the two halves of the outer mold together. And here I can see both sides, so it's easier to line up. Outside. All right, there's the outer mold. And again, we want this to be able to be disassembled so we can pull it off of the plaster once it's cured. I'm going to wipe everything down one last time. All right, and there we have it. One fully 3D printed custom mold for our very own form. At this point, I'm going to go ahead and double check to make sure that all of the bolts got into the threaded inserts. Sometimes there's a slight misalignment, and you might need to rock it around a little bit. So I'm going to go ahead and do that, and then we'll get set up for plaster. Here's the README created by Shapecast. It tells you the size of the pot, and then for the final molds, it actually tells you how much plaster you're going to need. So basically goes ahead and models the internal volume here so we can calculate the resulting plaster size. And it says basically it's 1.8 liters inside of here. And then I'm using USG #1 pottery plaster. And for that, basically you need 1 kilogram per liter. And I go ahead and round this up so you have a little bit of extra. Better have too much than too little. We're going to need 2 kilograms of plaster, and then we want a 70 to 100 ratio of water to plaster, so that means we need 1.4 liters of water, and that's exactly what I have here. I went ahead and measured those two out. So for mixing the plaster, I want to slake the plaster, so take the plaster and gently sprinkle it onto the water. That way the plaster starts to get hydrated. I let mine slake for 3.5 minutes at that point. Then I mix it as vigorously as possible for 4 minutes without introducing bubbles, which is a little bit hard. The more plaster you have and the narrower your bucket, actually the easier it is. Once we have all of that mixed up, we'll go ahead and pour it into the mold and let it sit. While this is slaking, I'll tell you a little bit about what I've learned about plaster. So plaster seems to be one of those things where there's a whole bunch of different opinions around the way to mix it up. I've tried to basically follow the manufacturer's recommendations as much as possible. One of the interesting things I've learned is that the strength of the final plaster is dependent upon how strongly you mix it. As soon as you start applying the mechanical energy, the magic chemical reaction in the plaster starts to happen, and that starts the setting as well as starts forming the strength of the plaster. You might be tempted to go ahead and mix it more gently so that you don't introduce bubbles. However, doing so will compromise the strength of your resulting mold. You'll get some plaster out at the end, but you might not be able to get as many casts out of it as you would otherwise, or it might break very easily. And one of the things that's different about pottery plaster relative to other plasters like hydrocal is basically the porosity of the final plaster. The pottery plaster has a bunch of pores in it that helps absorb the water from the slip. Okay, that's slaked for 3.5 minutes. All right, there's 4 minutes of mixing. Then we'll pour the plaster in, and from high is good if you can manage it. So a thin stream. So the bubbles have a chance to break on the way down. And it's a good thing we mixed up extra plaster because it basically used it all. Pat out some of the bubbles. I'll do that a little bit more, and we'll go ahead and let this cure and come back to it when it's ready to start demolding. Plaster's all set now. Break that out later. I'll just undo the bolts. The ring should just come off, just like that. Perfect. And the gasket's doing its job, sealed so we don't have any leaks. There we go. Looking pretty good. few little bubbles here. We'll see how those turn out. So while this is soft, just go ahead and scrape it down with that flash line. And since I didn't fill the mold completely, there's a little bit of a rough spot here. Alright, that just makes the foot a little bit bigger, so it'll be easier to pour. Alright, and last is the inner mold. Normally I've been pulling this right away. I think I'm going to let it sit for a while longer and firm up a little bit. Sometimes I'll get a little bit of chip out on the top when I pull out the inner mold. By letting it cure a little bit longer, it'll get a little bit stronger, and hopefully that won't happen. Cooling down a little bit more won't hurt either. I took the outer mold off after about an hour, and it's been another hour and a half now, so basically 2.5 hours since I poured the plaster, and time to get the inner mold out. And usually this is very stuck, so I like using this here. This is a mixture of isopropyl alcohol and water, so it stays liquid at freezer temperatures, and usually, oh yeah, it just comes straight out. And it looks like we have a great mold. We have basically no chip out here. There's a couple of tiny little chips here. Plaster really doesn't like hard corners. And I don't see any bubbles. So it's going to be harder now, but I'm going to go ahead and clean up this part right here. This is basically where the two pieces screwed together. And this is really just to make it nicer to handle. And there we have it, one brand new mold. I'm going to go ahead and let this finish curing and dry out, and then we'll slip cast a new pot. Let's make the very first pot. Our mold is all ready. Only thing left to do now is to pour in the slip. So for that, I like using my bucket with the spigot over here. Just go and put it under, open up the tap, pour out the slip, let it fill up the slip well, just like that, and then close it off. There we go, all full of slip. I'll usually let the new mold sit for about half an hour. I think I'll give this one 25 minutes. In that time, the wall will have formed, and then we'll dump out the excess slip. There we go, and then I'll just sit it upside down for a while to let it drain. In my case, a while is about half an hour again. So we'll come back then and trim the new bowl and pull it out. And here's our pot. And I can tell this has already started to release. Let's go ahead and give the rim a quick trim. Basically just cut down straight to the slip well. Go around. I'm doing a bunch of these. I'll pull out my banding wheel, but just for one. And spin it like that. This here will go into the reclaim. There we go. The rim's trimmed just like that. I noticed one slip casting artifact. It looks like I didn't turn the pot upside down fast enough. So I'm going to clean this up real quick with a sponge while it's still supported by the mold. Basically, this is the slip dripping down. There we go, that looks good. Now I need to flip this out. Sometimes I can palm these, but then I risk distorting the rim, and that will often show up in firing because you're reorienting the clay particles. So I have to take a piece of cardboard that's cut out basically to fit inside the slip well. I can use that to catch. Put that down, flip it over, and lift it out. And there we have it, our brand new pot. It looks really good. I don't see any flaws. The seam lines that were in the original are gone. Maybe if you look really closely, you can see some hints of the layer lines, but I suspect once that's fully fired, you will never notice. All right, at this point, I go ahead and transfer it over to a wear board so it can start its drying process. You want it to dry nice and slowly so it doesn't develop any cracks. Once it's closer to leather hard, I'll take a sponge and smooth off the rim so it's rounded over as opposed to that sharp cut edge that we just made. And then it goes through the rest of the ceramics process just like any other pot. Once it's bone dry, we'll do a bisque firing. At that point, we'll glaze it and do a glaze firing, and we'll have our final bowl, just like the idea we started. Right now, this is substantially larger, but Shapecast took into account our clay shrinkage so that we will get a bowl that's basically this size. It'll take a while before I actually do my final glaze firing, so if you're curious about what this looks like, go ahead and follow me on Instagram, and I'll eventually post a picture there. But it'll probably be a little while. If you want to try this yourself, basically going from idea and a sketch through 3D printing into a new plaster mold to slip cast in, go ahead and sign up for Shapecast. There's a link in the description. If you have any questions or comments, let me know. Thanks.